So I'm going to go through and explain calorimetry really quickly. And all calorimetry is that process of dropping a heavy metal into water to determine the specific heat or just the heat capacity of that metal. So this is calorimetry. And I'm just going to go through and show you what's going on and give you some phony numbers to explain it again, just to make sure we understand. So calorimetry. All right. So you start off and you create a container that you hope is well insulated. And what well insulated means is that you're not going to lose a lot of energy. So we used 2 styrofoam cups. We had a cardboard lid. Obviously, it was not perfect. And it's not going to be in first year chemistry class. So what we did was we heated up a metal in boiling water. Okay, and so you measured the boiling water, which was actually the initial temperature that the metal was. So let's say, I don't know, it was exactly 100 degrees. Okay. You also measured the initial temperature of the water that was in the calorimeter. And let's say you got, I don't know, 22 degrees. Other things that you found was that the mass of the water, I don't know, some people got around, let's say 140 grams. And the initial mass of the metal, I honestly don't remember, so I'm going to guess around, and let's say 20 grams. Okay. The only other thing that I know is that the specific heat, C, of water is 4.18. I think it's just 4.18 joules over gram degree Celsius. So here's what I'm going to do. Since for water, I know, based on the formula, Q equals mc delta T, I know the mass, I know the C, I want to find the delta T, and then I can find the Q of the water. So what we did was we took the really hot metal, we put it into the water, and we allowed it to reach a temperature at which it wasn't changing anymore. So let's say it reached, I don't know, 24 degrees Celsius. Now, since both the metal and the water are at 24 degrees Celsius, that's going to be the final temperature, the TF, of both of them. Okay? So the first thing that you need to do in these problems is figure everything out for water. Okay? So for water, I'm going to first calculate my delta T. So delta T is TF, so T final, which was 24, minus the initial temperature, which was 22. So it increased by 2 degrees Celsius, which is fine. I know my mass. My mass equals 140 grams. I also know my C, which is 4.18. And it's joules over gram degree Celsius. And so now I can just plug it in and find the amount of heat, Q, that the water absorbs, because it's increasing in temperature. So if you increase in temperature, that means that you're gaining heat. Okay? So Q equals 140 times my C, which is 4.18, times my change in temperature, which is 2. And so when you plug that in, 140 times 4.18 times 2, you get 1,170.4. 1,170.4. Obviously, these aren't going to be your numbers because I just made up numbers, and it's going to be joules. Now, here's the why calorimetry is, we call it calorimetry, why we do it. The whole point is this step right here. Now, we took a metal and we added it to water. That water absorbed 1,170.4 joules. Where did that heat come from? How did it absorb that heat? Well, it got it from the metal. So the metal actually lost this amount of heat. We're assuming no other heat goes anywhere else because we're assuming that the cup is a fantastic insulator. Is it really? No, heat's going to be lost, but we're going to assume that it's not. So the Q, we're going to now deal with the metal. The Q of the metal is just going to be the negative of this, because that's how much heat the metal lost. Awesome. Let's figure out what else we know. We also know we can calculate the delta T. Now, the final temperature of the metal is still the 24 degrees Celsius that the water's final temperature was. So it's going to be 24 minus the initial temperature of the metal was the metal at the boiling point, so it's 100, so 24 minus 100. And your delta T is going to be negative 76. So don't freak out and not make this negative. If you notice, your Q is negative, so if temperature decreased, that means energy was lost, and we represent losing energy or losing heat with a negative. So that makes sense. If you lost temperature, that means you've lost heat. So that works out fine. I don't know the C of my metal, so I'm going to leave that blank. I do know the mass of my metal. The mass of my metal is, I said 20 grams. Probably was different than that, but I'm just guessing. And so the whole point of calorimetry is now to solve for your C. If you notice, when we're dealing with water, we're solving for Q because we knew C. Now we know Q because we're assuming it's just the negative of whatever the water heat is, and therefore we can solve for C. So we're going to plug and chug. I know my Q for the Q equals MC delta T. It's negative 1,170.4. So there's my Q. I know my mass. It's 20. So Q equals M times C. I don't know my C, so I'm just going to write it there. Times my delta T, which is negative 76. So I do 20 times negative 76. And I get 1,520. So I'm going to divide both sides by that so I can get C by itself. So negative 1,520, negative 1,520. Okay. So 1170.4 divided by 1520, and we get that my C equals 0.77. So let's look at all of these values. I've got 20 grams here. That's 1 sig vig. The rest have about 2 or 3. So 0.77 is going to become just 0.8. Now the important thing for you to do now is figure out units. So the units for Q will always be joules. So it's going to be joules here. And then I divided my joules by degrees Celsius. So over degrees Celsius. And so sorry, degrees Celsius are here, and grams. Okay. So here's my C, and that is the entire purpose of calorimetry, to determine the specific heat of a metal. Now the reason why, just like with density, your specific heat can tell you the identity of the metal. Okay? And so 0.8 might be the specific heat of a metal, like I mean any metal. You just look it up in a table or look it up online. And that's it, guys. That's calorimetry.